Welcome PM1 students. I thought today I would do some quadratics and functions questions from the June 2021 PM1 Cambridge exams. So here we go. So I've got the equation of this curve here, which has got a whole lot of k's in it, and k's are constant, and we've got this line here which is a tangent to the curve. That means it touches at one point alone. So what we're going to do here is we're going to make the line and the curve equal to each other. So that's going to be my first step. And what I'm going to try and achieve here is get everything across to one side, and then I'm going to use my discriminant, because the discriminant will be equal to, so b squared minus 4ac equals 0 if it's a tangent, right? So that's what we're going to do here. Okay. So let's bring, I guess we can expand, so we're going to get 2k x squared. Oh, wait a second, no, we probably don't want to do that actually. So the next line, I'm going to bring the 3x across, so it'll be negative 3x. So I'll have x into negative k, negative 3. So if we expand this, we get negative kx, which we've already got here, and we'll also get negative 3x, which is the result of bringing that across the left hand side. So that's that bit there. And then minus k minus 2, and we've got to get this minus 4 across. So if I do that minus 4, I could turn this minus 2 into a minus 6, because when I expand it like that, I'm going to get the positive 6. So expand this, you get positive 2, and add 4 to it, you get positive 6. So that's where I'm coming from there, and then obviously that will mean I'll have a 0 on the right hand side there. And now I can use the discriminant formula. Okay, now b is going to be this minus k minus 3, and I'm going to square that. Then I'm going to take away 4 times my a value. The a value is the coefficient of the x squared term, so it's going to be 2k minus 3, that's a, and then c is obviously, yeah, I would probably maybe rewrite this bit here as plus 6 minus k. I think that's what I'm going to do. So 6 minus k, I've just applied that negative to that whole bracket there. Okay, so that's probably what I'm going to do. And this should be equal to 0. So I'm applying the discriminant. Now let's see what we get. So we get k squared plus 6k plus 9 minus 8k plus 12. Ooh, hold up, let's go back a bit here. Maybe what I'll do first is I'll expand the double brackets, so I'll get 12k minus 2k squared, then minus 3 times 6, so negative 18, plus 3k equals to 0. Let's gather our terms again. So we've got 6k plus 9, and then minus 4 into, now minus 2k squared plus 15k minus 18 equals 0. Now we're ready to expand that bracket there. So we're timesing everything by minus 4, so that gives us positive 8k squared minus 60, oh that's a k, isn't it? 60k, and then plus 72. Now let's see what we get there. So I'm thinking it's 9k squared, and what have we got? negative 54k. I'm just gathering the like terms here. And then I've got 72 and 9, which is positive 81, and that's equal to 0. Now it looks to me like we can divide out by 9, and you can see that k is equal to 3. So 5 marks there, but a relatively straightforward question actually, I think. Okay, the next one is a functions question. We've got, so that was quadratics. So the functions question here, we've got these two different functions, f and g. We've got some ranges here, which is important. And a is a constant, and I've got to state the range of f. Okay, well, f is that one there, and you can tell by looking at it, because they've completed the square here, you can tell that it has a minimum point at 2, minus 4, and since we're using x is greater than or equal to 2, we know that fx is greater than or equal to minus 4, because it includes that x is 2 value there, so that's lovely. Now we're trying to find the inverse function, so the steps I do is I write it as y equals, you want to use for quadratics the completed square version, which they've already given to us. I'm going to square root both sides, so I get x minus 2 equals plus or minus the square root of y plus 4. And then x equals 2 plus or minus the square root of y plus 4. Now, I've got to decide whether I want the plus or minus there. You won't get a full answer mark unless you decide which one it is. Now, the simple way I've been talking to you about it in class is you can see from which side of the equation you defined your domain with in the function was on the right hand side of the minimum point, so that means we're going to be using the plus. If it had been the left hand side, then we'd be using the negative. Oh, but probably my last step, which I haven't done here, is I need, I'll change it to y equals 2 plus or minus the square root of x plus 4, and then down here I need to, yeah, I should have done that earlier. So there we go. Now, given that a is equal to negative 5 over 3, we've got to solve the equation, blah, 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 blah. Okay, so we're going to go x minus 2 all squared minus 4 is equal to negative 5 over 3 x plus 2. We are going to expand the brackets on the left hand side, so we get x squared minus 4x plus 4 minus 4, and then we're going to add this other nonsense across, so plus 5 over 3x. That's a horrible looking 3, isn't it, really? Let's rectify that. Minus 2 equals 0. Then we are going to add it all up. You know what I'm going to do? I'm just going to times everything by 3. So I get 3x squared minus 12x. The 4 minus 4 is gone, so plus 5x minus 6 equals 0. So you can see that they cancel out. When I times the 5 over 3x by 3, I get rid of the third. Yeah. Now we can see this is 3x squared minus 7x minus 6 equals 0. And I guess we probably, can we factorize that? I think we can. Yeah, so why don't we go 3x here and then x here. And then if we pop a minus 3, will that work? Minus 3 here and a plus 2. Negative 9, 3 times 3 is negative 9, plus 2 is negative 7. Yeah, perfect. So x is equal to negative 2 over 3, or 3. Now, be careful at this point, because you need to go back and look at the original domains, which I've highlighted. And we are told that x for the function fx has to be greater than or equal to 2. So we can actually ignore that solution, because it's not part of the range sorry, the domain for fx. Okay. Now, right. It is instead given that g inverse function 12 equals 62. Find the possible values of a. So what we're going to do is we're going to put the 12 into the inverse function, which is so that gives us what's the square root of 16 is 4, so 6. Now then we're going to go that into g, and this is all meant to equal 62, right? Now we're going to put so we put that into that 6 into the value for x, so it's 6a plus 2. And now the last step, we're running out of room. Let me just scroll down a little bit. We're going to put that 6a plus 2 as a value for x. So we'll have a into 6a plus 2, that's my x value in the last line, plus 2 equals 62. So we should get 6a squared plus 2a plus 2 minus 62 equals 0. So I just pull that all across the left hand side. And so finally I get 6a squared plus 2a minus 60 equals 0. Divide everything by 2. So we get 3a squared plus a minus 20 equals 0. Sorry, not 20, dividing by 2, so 30. Okay, I think we can, again, can we factorize this? So chuck that there. Let's go, what about minus 3 plus 10, does that work? Negative 9 plus 10 is, yep, I think that's correct. And so therefore, a equals negative 3 over 10, or 3. Sorry, negative 10 over 3, not negative 3 over 10. Negative 10 over 3, or 3. So that's the June 1 paper. Moving right along onto the June 12 paper. Okay, we've got a what are we doing here? So we need a 4x. Plus. I think it should be minus, shouldn't it? Minus 3. Does that do it? Minus 9 plus 10. I think that's it. So what I did here is I'm thinking, how do I get this negative 24? I know that the first bit has to be 4x, so that gives 4x. So when you're expanding this, right, obviously you're going to get the 16x squared. Then you're going to get 4ax and then another 4ax. So you're going to get, I guess, 4 times a plus 4 times a, or I guess 8 times 2a equals 24. 8 times a equals 24. So that's how I got the 3 here, because 4 times negative 3 is negative 12, and you're going to do that twice, which gives you negative 24. And then obviously that minus 9 that I've chucked out there, it's because I've sort of done that, kind of completed this, like I complete the square move, and I've got to get rid of the extra 9 that I have from when I expand this 4x minus 3. So last line would be to go plus 1, because the 10 minus 9 is plus 1. Okay, so that's fine. It's given that the equation blah 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 has exactly one root. Find the value for this root. So if it's got one root, so if you think about the equation, we've just drawn this. This is our 4x minus 3 plus 1 graph. Right? Where is there one root for it equaling a particular y value? Well, obviously at the minimum point here. Okay? When there is one root, it must be the minimum point. Thus, k equals 1. Now why does k equal 1? Because the minimum point occurs when at 3/4, right? You make the bracket equal to 0. And then the y value, of course, will be this bit here, which is 1. So when k equals 1. Now, therefore, what does x equal? 3/4, isn't it? Now, the next one, we're taking a graph and we're transforming it in this particular way. So here's our original, and we've got to describe fully the transformations. So let's start off with this bit here, and this is a translation of 1, 0. In the positive horizontal direction. I've given that with my vector there anyway. So that's nice. The other thing is this 2 here, and this is a stretch, isn't it? Along the y-axis. So stretch, scale, factor 2 in the vertical y direction. And there we go, we're done. Now, the next one, the curve y equals sine 2x minus 5x is reflected in the y-axis and then stretched by its scale factor 1/3 in the x direction. Write down the equation of the transform curve. Now, if it's reflected in the y-axis, so it's like a horizontal reflection. The first thing is we're going to go y equals negative sine 2x and then plus 5x. That's the so I've done my reflection, and then the stretch by the scale factor of 1/3 in the x direction. So I've got to now do that. Now, if we're stretching it in the of a factor 3, that means every x is going to be times by 3. So, so it'll be negative sine 6x, and then the plus 5x will be plus 15x. So there we go. That would be my final answer there. Okay. Now the next one, we've got this function here. Blah blah blah. We've got to find and simplify an expression of f(x). So we're putting this into itself. So it will be 2 bracket 2x squared plus 3 all squared plus 3. And now we've got to simplify it. So that would be, I guess, 4x squared plus 6x plus 12x squared plus 9 plus 3. Now let's take that over to here. So we'll get 8x squared. Not 8x squared, that should be to the power of 4. 8x to the power of 4 plus 24x to the power of 2 plus 18 plus 3, because it's 2 times 9 is 18 plus that 3 we've already got, so 21. I guess that's what they're wanting. Now I've got to solve the equation that if x equals 34x squared plus 19. So probably, I guess we could go 8x to the power of 4 plus 24x squared plus 21 equals 34x squared plus 19. Now let's bring everything across here. We've got 8x to the power of 4, subtract 34, so that would be negative 10x squared, and then subtract the 19, so that's plus 2, equals 0. I guess we could divide everything by 2, so we get 4x to the power of 4 minus 5x squared plus 1 equals 0. And, I guess we could go 4x squared, bracket, 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 equals 0, put an x squared here, go minus 1, like that. I think that works. Minus 4, yeah. Okay, so x squared equals 1/4 or 1. So x equals, I guess, plus or minus 1/2 or plus or minus 1. But let's just go back and have a look at the domain here. And so therefore we can actually say, we can rule out the negative values. There we go. So that's June 1, 2. Now let's do one more, I think. June 1, 3. Okay. The function f is defined in this manner. And we've got a domain here. And it's given that f is a decreasing function, which means, the gradient is negative. This is actually really a differentiation question, but I don't know why. Probably because I saw a function and just assumed it was a function question. But we can do it, right? Let's do it. Dy dx equals, we're going to take this, we're going to times it by the 2, and then times it by the third. That'll just give us a 1 outside, and we get 2x. I feel like I've done this in a recent video anyway. And that'll be to the power of 1/2 and then minus 2. And if it's a decreasing function, that means the gradient is less than 0. And so we go like this. Yeah, I definitely have done this recently. I'm going to square both sides. And then so 2x is less than 5. X is less than 5 over 2. So I think that's pretty easy. Okay. Now, what else have we got here? A line equation with this line here is a tangent, so it touches at one point to this one here, and we've got to find the possible values of constant m and corresponding coordinates of the points at which the line touches the curve. Okay, so if they touch, we're going to make them equal to each other, like this. Then we're going to bring everything across to one side, and that would be minus 4 minus m. I'm just factorizing that out. Plus 3 plus 9, so it's plus 9. So there we go. I took the mx away, so from both sides, so I end up with minus 4x minus mx, and I can factorize that x into minus 4 minus m. Okay, that's all I've done there. Now, excuse me, if it's a tangent, we know that b squared minus 4ac is equal to 0. So let's do b, which is minus 4 minus m all squared, minus 4a, which is 1, times 9. That ought to be equal to 0. So we get 16 plus 8m plus m squared minus 36 equals 0. So m squared plus 8m minus, what's that, 20, 20 equals to 0. We can factorize this, I think. Is that right? I think it is. 10, take away 2, yep. So m equals 2 and negative 10. Okay, so those are the two values. Now, if it's 2 and 10, then we've got one line is y equals 2x minus 6, and the other one would be y equals negative 10x minus 6. Now, we've got to find out where they touch. So, if y equals 2x minus 6, if m is 2, then we're dealing with a situation like this, I guess. So we're going to go x squared minus, wait a second, would it be minus 6x, I think, yep, minus 6x, because that m would be 2, so minus 4 minus 2 is minus 6, and then plus 9, so just for those who are a little unsure, I'm dealing with this line here, plus 9 equals 0, so you can see here that x equals 3, and we can chuck it into here. Y is equal to now mx, so 2 is m. 2 times 3 is 6, take away 6, y equals 0, so coordinates are 3, 0. Now, if y equals negative 10, now we're going to plug that into that pink highlighted section, we'd get x squared plus, now we'd have minus 4 minus 10, which is like minus 4 plus 10, which is 6. So we should have 6x plus 9 equals 0. And so you can see that x plus 3 all squared equals 0. And so x equals negative 3. And if we plug that into our equation up here again, minus 3 times negative 10 is 30, take away 6 is 24. So I think it should be negative 3, 24. So these are our two results. Okay, hope that's right. Let's move on. So the next one, functions f and g are both defined for x is a member of the set of real numbers, and blah 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 blah, and we've got to complete the square for both of them, and then express gx in the form of blah. Okay, well, let's complete the square for the first one. So that's x minus 1 all squared minus 1 plus 5 equals x minus 1 all squared plus 4. And gx, we can write that as x plus 2 all squared minus 4 plus 13, which is equal to x plus 2 all squared plus 9. Okay. Now, we're going to look at those two equations, and we're going to try and write gx in this form here. So what have we done to gx to get fx? Sorry, what have we done to fx to get gx? So we could go f, and then you can see probably that what have we done? We've added 3, so x plus 3. And in that case, yep, and then we're just going to add on a 5. So we've shifted it to the left by 3, and we've lifted it by 5. So this is a transformation. Okay, so we're going to use that information down here. So first of all, translation by -3 in x direction. So that's like this. So that's the first one. And number 2 is translation of that should be sufficient, I imagine. I've given the vector anyway. Okay, this is long. Okay, right, what have we got here? Functions f and g are defined as follows. Okay, so we've got to put g into x. So g is 1 over 2x. So I'm going to go and put this into f. Now, that becomes my x. So I'm going to have 1 over 2x plus 1 all squared minus 1. And this is meant to equal 3, apparently. That's what they're telling us. So I'm going to get 1 over 2x plus 1 equals 4. Let's see. I'm going to rewrite it as 1 over 4 equals 2x plus 1 all squared. So what I did there is I just, I guess, cross-multiplied is a way of looking at it. And I guess I could at this point square root both sides. So plus or minus 1/2 equals 2x plus 1. So 2x equals, and then if we're subtracting 1, it would be 1 minus 1 plus or minus 1/2. And so x will equal -1/2 plus or minus 1/4. And that gives us two results. -1/2 minus 1/4 is -3/4, I think. And the other one is -1/2 plus 1/4, which would be negative 1/4. Whoops, a daisy. Negative 1/4. But we've been given this information here. X is less than 1/2, so this would be it. X equals, that's my final answer. Now I've got to find an expression for the inverse. So I'm going to write y. So I'm going to write fg x, which I had in the previous question, is equal to 1 over 2x plus 1 all squared minus 1. I'm going to swap my x's and y's. And maybe at the same time, actually, I'll bring that one across. So x plus 1 equals 1 over 2x plus 1 all squared. I'm going to square root both sides. So plus or minus x plus 1 equals 1. Oh, I was meant to swap my y across, wasn't I? Let's just fix that up. That should be there. There we go, that's better. Now, at this point, I'll rewrite. So I can write it as 2y plus 1 equals plus or minus 1 over square root x plus 1. So I just cross-multiplied each across the 2y plus 1 and then divided across the plus or minus square root x plus 1. That's all I've done there. Then I can add, I'll subtract the 1 from both sides. So, whoops. So I'm going to just get this here. And y equals -1/2 plus or minus 1 over 2 square root x plus 1.
I think that's right.
Now, I've got to decide whether I want a plus or a minus. And if I look over here, I can see, I can see the values here for the domain, suggesting to me that I need to have the minus. But there is a way of checking if you're not sure. So maybe I'll just give you, I need the minus. And I can rewrite, I'll come back to that in a second. I can rewrite 1/2 over square root x plus 1 as 1 over square root 4 into x plus 1. Okay, I hope that makes sense because square root of 4 is 2. So that's just another nice way of writing it. Now, as promised, let's just check. So if we're only allowed to put in numbers less than 0 and less than minus 1/2 in here, so why don't we just chuck in a number like, let's pop in a number like, just make life easy for ourselves, 4, minus 4, or minus 5, okay? X equals minus 5. Okay, so we pop it into this function here. We pop it into our original function f(g(x). Okay, so pop it into here, into f(g(x), which is, what did we say it was? 1 over 2x plus 1, all squared minus 1. Okay, so we pop that in there. So we get 1 over negative 10 plus 1, so 1 over negative 9, and we square that. So 1 over 2 times negative 5 plus 1 equals, we square the answer, which gives us 1 over 81, and then we take away 1, which gives us negative 80 over 81. And then we pop that into this formula here, and we see which one gets us back to the negative 5 that we popped in. So let's start with the plus. Well, let's start with the minus, because we know that that works. Minus 1/2 minus, chuck this in your calculator, 1 over 2 square root, and then we're going to go negative 80 over 81 plus 1. Okay, and that gives us negative 5. But if you go back and try it with the plus, so just scroll back on your calculator, instead of having minus 1/2 minus blah, go minus 1/2 plus, and what do you get? Well, you get 4, which is not what you started with, okay? So, and is outside the domain that you've been given at the beginning. So that's one way you can check if you're a little bit unsure of how to do these. Alright, well, I hope that's been helpful. If you do have any follow-up questions, happy to answer those in class. If anything's been unclear, when we meet face to face, I might be able to clear those up a bit more easily. Alright, take care. God bless.